Hello students, welcome you all. In my today's lecture, I will analyze the electrocyclic reactions by Woodward Hofmann rule. In my last lectures, I told you the analysis of electrocyclic reactions by the conservation of orbital symmetry method, frontier molecular orbital method, that is FMO method, and Huckel-Mobius method, or also called as the PMO method. So let's see its analysis of electrocyclic reactions by Woodward Hofmann rule. So already I have told you the rule, selection rule for this electrocyclic reaction, that is two type of electrocyclic reactions, 4n electron systems, and we read for 4n plus 2 electron system. So they can be analyzed under thermal condition or under photochemical condition. Under thermal condition, the end orbitals will undergo bond rotation in case of 4n electron system, and under photochemical systems, these orbitals undergo disrotation. And opposite is the case for 4n plus 2 electron system. Okay, so this rule we have to analyze with the help of Woodward-Hofmann rule. So according to this Woodward-Hofmann rule, if system is thermally allowed, the system is thermally allowed in what case? The system is thermally allowed when this is when the sum of (4q plus 2s) component and 4r a component is coming out to be odd. Okay, if the sum of these two components is coming out to be odd, then system is thermally allowed. Okay, now what is this Q, what is this R, A, S, that I will explain you. Now suppose if sum of second case, suppose the system is photochemically allowed when the sum of 4q plus 2a component, here in place of S now I have written A, and 4rs component, in place of A here I have written S. So if sum of these two components is coming out to be odd, then our system is photochemically allowed. Okay, so let's see the meaning of here Q or R, S or A. Now suppose two type of system, either 4q plus 2 system or the system may be 4r system. So when we say the system is 4q plus 2 system, so suppose if 4q plus 2, this is equal to number of pi electrons. Suppose if we put 4q plus 2 is equal to number of pi electrons, and suppose if we get q is equal to 1, 2, 3 like this. Okay, then system is or 0, we can say 0, 0, 1, 2, 3. Then system is 4q plus 2 system. Then system is 4q plus 2 system. Okay, so this is one of the case. So I will make here, suppose I take this butadiene, or suppose I take hexatriene. Suppose I take hexatriene, and this in hexatriene, suppose I put 4q plus 2 equal to number of pi electron. So number of pi electron here is 6, and here q is equal to, now if you will see 4q, this is equal to 6 minus 2, that is equal to 4, and q is coming out to be 1. So here q is coming out to be 1. So that's why such system may be called as 4q plus 2 system. Now suppose I take butadiene, this system, and if you put 4q plus 2, this is equal to 4. Here how many pi electrons are present? Number of pi electrons? 4. Then here q is not coming out to be, here 4q, this comes out to be 2, and it is equal to 1 by 2. So q is not coming out to be either 0, 1, 2, 3. So that's why such system can't be called as a 4q plus 2 system. Now next thing, if 4 are, suppose if 4 are, so two type, one is 4q plus 2 or 4r. So if 4r is equal to number of pi electrons, if we put 4r is equal to number of pi electrons, and we get q is equal to 0, 1, 2, 3, then system is called as, then if we get r is equal to 0, 1, 2, 3, then system is 4r system. Okay, now let's see here, put 4r. If we put 4r is equal to number of pi electrons, so number of pi electron is 6. So r we will get how many, what is the value of r? It is 3 by 2. So r is not equal to 0, 1, 2, 3. That's why it is not 4r system. Now if you will see, if 4r is equal to, suppose I put 4, number of pi electron here is 4, and here we are getting r is equal to 1. So here we are getting r is equal to 1. That's why it is 4r system. In the same way, suppose if we take, if you will take the this one, octatetraene. So in octatetraene, suppose this 4r, this comes out to be 8. So this r, this is equal to 2. So r is coming out to be 2. That's why this is our 4r system. And here this rq will not come out to be, in this case, suppose I put 4q plus 2 is equal to 8. So this q, 4q, this is equal to 6, and q comes out to be 3 by 2. So that's why it is not 4q plus 2 system. Okay, so like this we may understand for this, what is this 4q plus 2 or 4r system. Now let's see what about this, what is the meaning of this A and S. What is the meaning of this A and S? Now this A and this S. S means when the end lobe, which combines to form a bond is on the upper side. Suppose this is the case. Suppose for the bond formation, if two upper lobes, both upper lobe is involved in the bond formation, then it is called as the S component. It is S component. And for bond formation, suppose one upper and one lower lobe is involved. One upper and one lower lobe is involved in bond formation. Okay. Then such system is called as the A component. or we may also see, suppose this is supra and this is intra, we may also call it, but so this is S component and this is A component. Okay, so either we know that the bond formation may occur via disrotation, and here the bond formation may occur via the conrotation. No doubt this bond will form when the both orbital will move in opposite direction. Okay, so it means when both orbitals move in opposite direction, it is S component. If it is moving in the same direction, both orbitals are moving in the same direction, then only these two opposite lobes may combine. So this is the conrotation. So this is the thing. Okay. For this first 4n electron system. For example, if suppose butadiene, it converts up into the cyclobutene. Okay. Now, so this is our what kind of system this is? What kind of component we can say? This is 4R. This is our 4R. This is 4R. Why it is 4R? Because this 4R, if we put 4R is equal to how many pi electrons? This comes out to be, this is 4. So R is coming out to be 1. So if R is coming out to be either 0, 1, 2, 3, then such system is 4R system. So this is 4R system. Now let's take two cases. First, suppose if S component is involved in bond formation. If S component is involved in bond formation. Okay, it means S component means both upper lobe is involved in bond formation. Both upper lobe is involved in bond formation. Okay, this is S component. Then it may undergo bond formation when disrotation of orbital takes place. Now you will get the bond. We will get our product. That is, we will get this product. Now suppose we have to check whether this condition is allowed thermally or photochemically. For this we have to see the sum of these two, or we have to see the sum of these two. Now here, so this is our 4R, and when S component is involved, then it is 4RS. This is overall, this is 4RS component. It means all this 4Q plus 2 system, 4Q plus 2S is 0. So that's why we can write 4Q plus 2S is here 0, because this is 4RS. In the same way, 4RA is also 0, so it's come out to be 0. So therefore it is not coming out to be odd, so that's why it is thermally disallowed. Thermally disallowed. So this rotation here is thermally disallowed. Now we should check for whether it is photochemically disallowed. So here 4Q plus 2A, this is also 0. This is also 0. But 4RS is 1. 4RS is 1. That's why it is coming out to be odd. This is coming out to be odd. This is odd number. That's why it is photochemically allowed. It is photochemically allowed. So same thing you can see for 4n electron system. 4n electron system, when disrotation occurs, it means it occurs only under the photochemical condition. Disrotation occurs under the photochemical condition. Now if suppose A component is involved in bond formation, second case I will take when A component is involved in bond formation, then again I will draw. If A component is involved means this is our A component, means when opposite lobes are involved in the bond formation, this is our A component. So what kind of system now it will be? It is 4RA component. Now they will undergo, the bond is only formed when this will undergo the conrotation, when they will move in a same direction. When they move in a same direction, then only this bond will get formed. This bond will get formed when they move in the same direction. Okay. So now let's check this conrotation of orbital is allowed under thermal condition or under the photochemical condition. So we have to check. So first of all, see this 4q plus 2s. This is 0, no doubt. And 4RA. 4RA, yes, this is 4RA. So 4RA component is 1. So the sum is coming out to be odd. So if sum out is coming out to be odd, it means this is thermally allowed. This is thermally allowed. In the same way, we should check for this one. 4q plus 2a. This is 0. But and also the 4RS. 4RS is also 0 because this is 4RA component which we have taken over here. So this comes to be overall 0. So it is not odd. So that's why it is photochemically disallowed. So we can check the rule for 4n electron system. If conrotation is only possible under the thermal condition. Okay, so this is for 4n electron system. We may take the 4n plus 2 electron system also. 4n plus 2 electron system. For example, when hexatriene converts up into cyclohexadiene. Clear? So what kind of system this is? This is our 4q plus 2 system. Now we may take two cases, either 4q plus 2s or 4q plus 2a. So suppose if s component is involved, if s component is involved, means both upper lobe of end orbitals are involved in bond formation. So the bond will get formed only when they will rotate in a disrotatory manner. So then only you will get the bond formation. So now we should check whether this disrotation is allowed under thermal condition or photochemical condition. Okay, so under thermal condition we should check the sum of these two components. So what kind of this component it is now? It is 4q plus 2s component. It is 4q plus 2s component. Now this 4q plus 2s, this is equal to 1 over here. 4RA, this is 0. So it comes out to be 1. And 1 is, this is odd. So if it is odd, it means this is thermally allowed. It is thermally allowed. Okay. Now we may also check for this photochemical case. So 4q plus 2a, this is no doubt, this is 4q plus 2s. That's why 4q plus 2a is 0 and 4rs is also 0. So this comes out to be 0. It is not odd. So that's why it is photochemically disallowed. Photochemically disallowed. So what we can see, 4n plus 2 electron system, this rotation is only allowed under the thermal condition. This rotation is only allowed in thermal condition. So in the same way, we may check for the A component. We may check for the A component. Let's see A component. So what is A component? when end orbital, in end orbital the opposite loops are involved. So this will only form the bond if it undergo the conrotation. So both orbitals move in a same direction. So conrotation. Now whether this conrotation is allowed under thermal condition or photochemical condition, we should check. So let's see. So this is our 4q plus 2a type of system, because here opposite lobes are involved. So 4, whether this is thermally allowed, let's see. 4q plus 2s, this is equal to 0, and 4ra, this is also equal to 0. This doesn't comes out to be odd, so it means this is thermally allowed, this thermally disallowed. This is thermally disallowed. In the same way, let's check for this photochemical case. 4q plus 2a, this is 1. This is one component, and 4rs, this is 0. So sum comes out to be odd. If sum comes out to be odd, it is photochemically allowed. So we can see for 4n plus 2 electron system. So for 4n plus 2 electron system, under when conrotation, the conrotation is only allowed under the photochemical condition. So this is about the electrocyclic, this is the Woodward Hofmann rule. So now we have analyzed this Woodward this rule, electrocyclic rule, for in various ways. Okay, one is the FMO method, and another is the correlation diagram method, and next that is the PMO method, and this is the last one is the Woodward Hofmann rule. So in next lecture we will see some of the problems related to the electrocyclic reactions. Thank you.